Imagine standing beneath an apple tree on a warm afternoon in England, watching a quiet young man stare into the branches, as if the entire universe is hiding there. His name is Isaac Newton, a solitary thinker who rarely smiled, rarely rested, and rarely forgave himself for not understanding something. He questioned everything. Why do apples fall? Why do planets move the way they do? Why does the world behave with such precise, invisible order? In our timeline, those questions led him to a discovery that reshaped human understanding forever: gravity. But what if he had never made that discovery? What if the apple fell, and the thought never came? Imagine that moment disappearing from history. Newton walks away without connecting the dots, without realizing that the same force pulling the apple downward is guiding the moon around Earth. The laws that became the blueprint of modern science vanish before they are ever written. And with that single missing spark, the world begins to tilt in a different direction. Not suddenly, not violently, but subtly at first, like a ship drifting slightly off course. The destination is no longer the one we know. Without Newton's laws, the scientific revolution loses its backbone. Early scientists still observe the skies, still record movements, still build theories. But none of them converge into a single, unified explanation. No universal law of gravitation. No three laws of motion. No mathematical system tying together every falling object and every orbiting world. Human understanding becomes fragmented, scattered across ideas that never quite fit together. Physics stays trapped in a fog for decades longer, and the consequences ripple outward. Astronomers struggle to map the heavens with certainty. Engineers have no clear foundation for calculating force, momentum, or motion. Every bridge, cannon, ship, and clock becomes a little less predictable, a little less reliable. The world moves, but humanity doesn't understand why. In our timeline, Newton gave us a roadmap. In this alternate one, we wander without it. Now imagine the impact on one of the greatest quests in human history: space exploration. Before rockets, before astronauts, before the dream of touching the stars, everything depended on one essential truth: gravity. The equations that launched satellites, guided spacecraft, and placed humans on the moon all traced their roots back to Newton. Remove his discovery, and the timeline of spaceflight slows to a crawl. The United States, instead of launching satellites in the 1950s, might still be debating their basic feasibility by the 1970s. NASA's greatest achievements could be delayed for generations. The moon landing, instead of being a defining moment of American innovation, becomes a distant aspiration. But the absence of Newton's work affects more than science or exploration. It reshapes the culture of curiosity itself. Newton's discoveries inspired centuries of thinkers, inventors, and dreamers. His work told humanity that the universe wasn't chaotic, it was understandable, predictable, and governed by laws we could uncover. Without that message, the rise of rational thought slows. The momentum of scientific progress weakens, and a world without progress becomes a world without breakthroughs. This alternate timeline forces us to ask a deeper question. How much of human advancement depends on a single idea born in a single moment of insight? If Newton never discovered gravity, would someone else eventually uncover it? Probably. But the delay might stretch from decades into centuries. Progress doesn't just slow, it shifts. New geniuses might never be inspired. Entire fields might never be born when they should have been. History becomes a puzzle missing its central piece. And as you imagine this parallel reality unfolding, take a moment to subscribe if you're new here. This channel explores the hidden turning points of history, the inventors who shaped our world, and the alternate paths humanity might have taken. Your support helps these stories grow, and it ensures you never miss the next journey into a world that could have been. Now picture the modern United States in this alternate timeline. A nation defined by innovation, speed, and technological dominance suddenly grows slower, more cautious. Without Newton's laws guiding early science, American engineering develops with hesitation. Steam engines arrive later. Railroads expand more slowly. Industrial growth loses its rhythm. And by the time the world steps into the 20th century, the United States is no longer decades ahead of its rivals. It is merely keeping pace, or worse, falling behind. As this new world takes shape, unexpected challenges begin to surface, challenges that will define the next chapter of this alternate history. But the real consequences emerge when America enters the age of flight. In our world, Newton's laws became the invisible foundation beneath every wing that ever lifted a plane into the sky. In the alternate world, aviation becomes a messy, unpredictable field where engineers rely on trial and error because the laws of motion aren't fully understood. The Wright brothers still experiment, still dream, still push the limits of human imagination, but the breakthroughs come slower. Aircraft designs remain unstable for years. Crashes are more common. The military hesitates to invest in something they can't reliably control. And when global conflict erupts in the early 20th century, the United States faces a battlefield very different from the one we know. Air power is weak, unreliable, and primitive. The planes that once defined American strength, speed, and strategy remain fragile machines that rarely fly long distances. Bombers struggle to hit targets. Fighters fail to compete with the unpredictable winds they barely understand. The wars America enters become longer, harder, and far more costly. Victory still comes, but with greater sacrifice and fewer technological advantages. Outside the battlefield, everyday American life also evolves differently. Without Newton's laws guiding early physics, technologies we now take for granted arrive decades late. Cars are slower to develop efficient engines. Electricity spreads unevenly because engineers lack the mathematical tools that help calculate force, load, and energy transfer. Factories run less smoothly. Machines break more often. Progress feels like walking through thick fog, one step uncertain after the next. The American dream of rapid innovation becomes a gradual climb, not a sprint. And yet, in the middle of this slower-moving world, something fascinating happens. A new generation of scientists begins to rise, driven by the frustration of a universe they can't fully explain. They gather in universities across the United States, arguing late into the night, trying to make sense of the forces that push and pull the world around them. With no Newtonian blueprint to guide them, they reinvent physics piece by piece. These scientists become pioneers in their own right, building the foundation that Newton once provided alone. Their discoveries come later, but when they arrive, they ignite a surge of American creativity that had been held back for centuries. By the mid-1900s, the United States finally pieces together a theory of gravity, strong enough to unify the scattered ideas of the past. The moment becomes a cultural turning point. Newspapers celebrate the breakthrough. Schools rewrite their textbooks. Young Americans look at the sky with a sense of possibility their ancestors never had. The nation feels as if it has awakened from a long sleep. Suddenly, everything becomes urgent. Rockets are designed at lightning speed. Research centers expand. The dream of leaving Earth finally feels within reach. But the world has changed. Other countries that once lagged behind now stand shoulder to shoulder with the United States. Space becomes a race without a clear leader. In our timeline, America reached the moon in 1969. In this alternate world, the question isn't who gets there first, but who gets there at all. Rockets explode more often. Missions fail repeatedly. The technology is crude, unstable, and unpredictable. Yet the determination is stronger than ever. The promise of understanding gravity fuels a sense of collective ambition, a belief that humanity must push onward no matter how many times it falls back to Earth. The first successful orbit might not happen until the late 20th century. The first moon landing could be a milestone of the early 21st. The moment still inspires the world, but it arrives in a century reshaped by delays. America remains proud, but it is no longer the unquestioned leader of innovation. Instead, it becomes one of several nations struggling toward the same goal, each held back by the centuries-old absence of one brilliant mind. The ripple effects reach even further. Without Newton's early influence, the mindset of American invention evolves differently. Industries mature slowly. Breakthroughs rely on collaboration rather than individual genius. Universities place greater emphasis on group research instead of solitary discoveries. And while the nation still thrives, it thrives in a world where technological dominance is shared rather than inherited. Yet there is something undeniably poetic about this alternate reality. Humanity, despite losing Newton's guiding hand, never stops searching. It never stops asking why. It never stops reaching higher. The world advances with hesitation, stumbles frequently, and learns painfully, but it still moves forward. The desire to understand the universe is stronger than any delay, stronger than any obstacle, stronger even than the absence of one of history's greatest minds. And that leads us to the final question this timeline forces us to confront. How different would our lives be if one apple had fallen, but the idea that changed the world had never fallen with it? Every invention we rely on, every journey beyond Earth, every moment shaped by physics, engineering, and flight, all of them trace their origins to a single spark of understanding. Without Newton, that spark comes centuries late. The world still discovers gravity, but not in time to make our timeline what it is today. If you'd like more stories like this, exploring how one idea, one moment, or one inventor can reshape all of human history, make sure you're subscribed. It helps this channel grow, reach new audiences, and bring more alternate realities to life.